So today, we're doing everything we have been doing, but we're adding another step to it. So we have talked about the graphing now. We have also talked about factoring and finding all the zeros. But on the ones where you had to find the zeros using synthetic division, I gave you a starting point. I gave you the first zero. Now we're going to do them where I'm not telling you the first one. You have to start from scratch. So we are now going to do the entire problem on our own. So to do this, we need the rational zeros theorem. I'm going to give you a minute to write it down, and then I will talk about what it means. So this is a way to come up with the things that could be zeros for our polynomial. It works for any polynomial as long as all of your exponents are integers, so no fractions or decimals for your exponents, or for your coefficients. All of the zeros that work are going to be of the form p over q. P is a factor of the constant. That means it divides the constant evenly. Q is a factor of the leading coefficient. So what we are going to do on our problems now is make a list of everything that could work. And then we're going to kind of use our graphing calculator to cheat a little bit and save a little bit of time and help us find one thing from our list that does work. Okay? So let's look at a problem. F of x equals 2x cubed plus 11x squared minus 7x minus 6. So first, on the problems before, when I gave you this and told you to factor it, I told you the first zero, and you would jump right in with synthetic division of that number. I'm not telling you where to begin this time. So we have to come up with a list of what could be a zero. To do that, we are going to find our p's and our q's. P is everything that divides the constant evenly. So what could multiply to give us negative 6? 2 and 3, 1 and 6. Now, can we agree that I could do like positive 2 and negative 3, or negative 2 and positive 3? So I could pick the positive or negative of any number. So when I list these, I'm going to put plus and minus on each one just to show that it could be a positive or a negative. So we said we could do 1, 2, 3, and 6. You're not telling me which ones pair up. You're just listing every number that divides that evenly. You do have to have that plus and minus because negative 6 is divisible by both positive 3 and negative 3.
Do they need to be like in any order?
Any order is fine. It doesn't matter.
So if it only went into like one of them was a negative and the other's a positive, then would you write the plus and just the minus? Or?
It will always, everything will always have a plus and minus. Q is the leading coefficient, so that's my 2. Tell me everything that divides 2 evenly. 2 and 1. Now, can we agree? It could be like 1 times 2 or negative 1 times negative 2. So both of those still need the plus and minus. Now we list the possible zeros. Possible zeros are going to be of the form P over Q. So 1 divided by 1 is 1. Again, I could do positive 1 over negative 1, or negative 1 over negative 1. So I could get positive or negative there. So everything always has plus and minus on this. So plus and minus 1. And we're just going to do every P over every Q. So 1 over 2 is 1/2. 2 over 1 is 2. 2 divided by 2 is 1. Since it's already on my list, I don't have to write it again. 3 divided by 1 is 3. 3 divided by 2, 3 over 2. 6 over 1 is 6. And 6 over 2 is 3, but that's already on my list, so I don't have to use it again.
So you're just dividing each one by p by the q.
Mm-hmm.
Seems too easy.
Okay. So these are the things that could work. Now, if it works, we know that means when you divide it, what do you get for your remainder? 0. That also means if you plug the number in, it gives you 0 out. We talked about that a long time ago, but if you just plug in the number, it gives you the remainder. So if I plug in a -1 and it gave me 0, that means it divides it evenly. So we have options for finding which of these numbers does work. We can just go through and methodically plug in every one of these until we find one. If that works, it's a good option, but we're going to cheat a little bit for the sake of time. Why don't we graph this polynomial, and we're going to try to estimate which one it might be. And that'll kind of give us, instead of just plugging in everything blindly, we can make an educated guess. Okay, we only need one number to start with. Can you tell, looking at your graph, where this thing crosses the x-axis? -6 is one of them? Okay. You have different options, like +1 looks like it works. You could start there. All you need is one of the numbers. I would try to avoid the fractions if you can. It's not a big deal if you can't, but it just makes things work out a little bit nicer. So once you find one that works, it's on our list, we are going to do synthetic division with that number. So 2 comes down. 2. Mm-hmm.
I don't know what I did wrong.
Okay. So 2 times -6 is -12. 11 plus -12 is -1. That gives us a 2x squared minus x minus 1. Alright, we have options from here. We could go back to our graph and find another one that works and do synthetic again with that one. We could also, now that it's just quadratic, what works? Quadratic formula. You can try box method. Keep in mind, the graph and this list are only going to tell you the nice, pretty zeros. So if you have any imaginaries or like things with radicals, the only way you're going to get those is from the quadratic formula. So let's just try box method here and see. So multiply to a -2 and add to -1. That would be okay, so this is 2x and 1, x minus 1. Alright, so the things that I asked for were the factored form and all the zeros. So my factored form is 2x plus 1, x minus 1, and what is the other piece? X plus 6. It was originally an x cubed, so I'm expecting 3 parentheses. My zeros, if we set each of these equal to 0, if 2x plus 1 equals 0, -1/2. If x minus 1 equals 0, and if x plus 6 is 0, okay, so we did that one on our own. I want to kind of explain, I always have somebody that asks me if they even have to make the list of possible zeros, since we kind of cheated and used the graph to get it. And the answer is yes. I want you to know how to do that, because sometimes you have things that the graphs are very ugly and you can't get it just from the graph, so that possible zeros gives us a starting point. And we don't have to have the graph. Once we have that list of possible zeros, we could just plug them in until we found one that equaled 0. So while I realize that we're kind of not totally using that. I do want you to be able to find it, so I will ask you on tests and quizzes to make that list just so I know that you're aware of which ones will work. If you look at our final answer, our zeros were -1/2, 1, and -6. Were all of those on my list of things that could work? Yeah. And so that's a good check as well. Okay. Questions here? So we're just going to do some more. So where do we start? P's and Q's. How do you find your P values? Okay. Q. Plus 6. So we need to do 2, 3, 1, 6. And you can list those in any order. Okay, possible zeros. So that's P over Q. So 1 over 1, 1 over 2, 1 over 2 would just be a half. But sorry, I was doing all my ones first. You can do them in any order. 1 over 3, and 1 over 6. Then we can do our 2. 2 over 1 is 2. 2 over 2 is 1, but I already have it. 2 over 3. 2 over 6 is 1/3, and I already have that. Okay, so now we need to find one that works. To do that, you can either plug these things into the equation and find one that makes it equal 0, or use your graph to kind of narrow it down and see what looks like it might work. Do you have one you think works? -2. If you weren't sure if it hit exactly, how would you check it to see if it worked? Yeah, you can use the calculator and find the intersection. You could just plug a -2 into this and see if it gives you 0 out. We can also, in our synthetic, we should get a 0. If we don't, then either we messed up our synthetic or it's not really a 0. We need to find something else. 6 comes down. This gives me 6x cubed minus 5x squared minus 2x plus 1. Can I do the quadratic with that yet? Okay, so that means we need to divide again. So we need another 0 that works. So you can go back to your graph and look again. You can graph this new one and look at that. But find me another 0. 1? Okay. So I'm going to do synthetic with 1 now.
And you use what you got out of the other one?
Yes. Alright, so 6 comes down, multiply and add. So this gives me 6x squared plus x minus 1. Alright, can we use that? Yeah, now we can do box method. So those multiply to -6 and add to +1. -2 and +3.
Oh, yeah. Wait.
What's wrong?
I was just confused. I'm not, you know.
Okay. Yeah.
Wouldn't it be negative or instead of positive?
Hmm?
Yeah, at the bottom. Wouldn't it be -1 instead of positive?
This?
Yeah.
Because it's a 1x in the middle. You wanted to add up to a +1. You multiply to get the negatives. Alright. So, our factored form. We have the 2x plus 1. We have 3x minus 1. What else do we have? X minus 1. It was an x to the 4th, we got 4 parentheses. My zeros, what makes 2x plus 1 equal 0? What about 3x minus 1? X minus 1? And x plus 2.
So everything that are possible is like everything that I could get.
Yes.
And then at the end, those zeros are everything I can get. So if I get something that's not in my possibles, it's wrong.
Yes.
So that's just.
Unless it's like an imaginary or something, because our possibles only include the nice zeros, so it won't include things with radicals or i's. But otherwise, if I got like a 5 down here,
Yeah.
5 wasn't in my possible list. I have a mistake somewhere.
Okay.
Okay. Is that okay? How are we doing with these? Need more? Let's try another one. Let's do this one. Okay. So, first step, what are my p-values?
1, 8, 4, 2.
Okay. Then what are my Q values? Yeah, it's just a 1x of 4, so Q is just 1.
If that happens, do we still have to write everything out even though it's...
If you want, so your possible P over Q is just going to give you all the same P values. If you just want to draw an arrow to your P values, that's fine. Okay. Then find one that works. What did you say? Negative. Okay, now what? Okay, so we could do 2. One comes down, multiply and add. So there's from a remainder, constant x and x squared, so we get x squared plus 4.
Could we just do x plus 2x minus 2?
If it was minus 4, we could. This, if I want to find the zeros here. So if you set this equal to 0, what would you have to do? Plus and minus. Square root of negative 4 is 2i. So my zeros are plus and minus 2i, 2, and negative 1. The factored form, we could do x plus 2i, x minus 2i, x minus 2, and x plus 1. So the i's weren't on my list of possible zeros because it only tells me the rational ones, the ones that can be written as a fraction. Any questions there? And I think I'm going to stop there. If that's okay. I wanted to give you guys some time to work. There's a math Excel assignment.